Algebra 1, Common Core, Unit 4, Section 8, Solving Inequalities. So most of Unit 4 has been solving equations, but in the last video, 4.7, we talked about set notation and interval notation and how to express inequality set solutions. And that's important for when you're solving inequalities like we're going to do just now. So solving equations is really the same as solving equations. Solving inequalities, is the same as solving an equation, except for one really simple rule, and that is that when you multiply or divide both sides by a negative, you need to flip the inequality sign. For example, look at this 7 minus 2x is less than 15 example right here. The first thing we did is subtract 7 on both sides, and that got us negative 2x is less than 8. So basically we're treating it just like an equal sign. I'm trying to get x alone, preferably on the left side. And so I minus 7 and so on. But then after that, the next step is divide both sides by negative 2. Because I'm dividing by a negative, I need to change my sign from a less than sign to a greater than sign. Now that only happens if I multiply or divide by a negative. Okay, not if I multiply or divide by a positive. If I have something like, 2x is greater than 10, I'm going to divide 2, I'm still going to get x is greater than 5. The sign is not going to change. But if I'm dividing by, say, negative 2, then that greater than sign is going to change and become a less than sign. So that's really it. Other than that, solving inequalities is just like solving equations. The big difference is, that rule about you might have to flip the sign. But really the biggest difference is instead of getting something like x equals 4, where I have an answer of 4, I might get x is greater than 4, where I have answers of 5, 6, 7, 8, 9, 10, 11, 12, and so on. All the numbers greater than 4. A lot of times, not in this case, but like I mentioned in the previous video, a lot of times you'll have questions that say, find the smallest integer that satisfies the inequality kind of thing. For x is greater than 4, the answer would be 5, because that's the smallest integer that's greater than 4. If it were greater than or equal to, now the smallest integer is 4. So, you have to be careful with sometimes those follow-up questions here. But, solving them is like solving equations. You just got to remember that if you multiply or divide by a negative, you flip the sign. All right, so let's just do a couple of problems here for practice. 2x minus 3 is less than 7. So I'm just going to do my normal procedure here. Add 3, add 3. I'm going to get 2x is less than 10, divide 2, x is less than 5. Let's see, the directions here say find the solution set of each. Express the solution set in set notation and graphically on a number line. So x is less than 5 on the number line. That would be an open circle because we're not equal to, pointing left for less than. In set notation, which I think what I meant to say there was probably interval notation, but that's okay. That's pretty much the same thing for now. So the interval notation, which we're really looking for, it's actually not the same thing, but you don't need to worry about set notation. So interval notation, we're going all the way down to negative infinity in this one. So it's going to be negative infinity and 5, and we have parentheses for both of them. Always have the parentheses for the infinities, but the 5, it's an open circle. It's not including the 5. That's why it's a parenthesis there. Okay, B. 3x plus 4 is greater than or equal to 1. All right, first thing I look for in these things is, do I need to distribute anything? No. Are there any fractions I want to multiply away? No. Do I have x's on both sides? No. If I did, I'd get it all to the left side, combine like terms. Is any factoring needed here? No. So this is a very, basic two-step, I'm going to try to get x alone. First, I subtract things away. So this will give me 3x is greater than or equal to negative 3, and divide. Divide 3. Divide 3. Now, this case, notice that on the first example, I did not flip the sign because I divided by a positive. Now, in this case, I'm dividing by a positive. I, again, am not going to flip the inequality sign. Even though this number is negative, that's not what we talk about when we talk about the rule about flipping the sign. It's if the denominator, if the number we divide by is negative, that's when we flip the sign. So we're not flipping here. Even though we're dividing a negative, we're not dividing by a negative. It's the difference between the divisor and the dividend. So this is going to be x is greater than or equal to negative 1. On the number line at negative 1, we're going to have a closed circle because it's equal to, and pointing to the right to infinity. So that's -1 and infinity, and we have the equal to bar, so we're inclusive, so I'll use the bracket for the -1, but it's always parenthesis for infinity. For C, here, similar question, nothing to distribute or fractions or anything like that, so we just get that x alone on the left -5. We're going to have -2x is greater than 8 and divide by a -2. And so this is that divide by a negative situation that now I need to flip that sign. So it's going to be, the sign was greater than, now it is less than. And the quotient here is -4. So x is less than -4. That's going to be -infinity to -4 parentheses for both. -4 on the number line, open circle, pointing left. And let's go, just trying to change colors there. It's not letting me. Hold on. Okay, sorry about that. All right, so D. Okay, again, nothing to distribute, no fractions, but I do see I have x on both sides, and I want to combine my x's to a single term. Preferably because of the inequalities, we like x on the left. I mean, we typically like x on the left for equations also, but it's not as important. But for inequalities, we like to say x is less than 4 as opposed to 4 is greater than x kind of thing. You could always adjust it, but if you have a choice between the left and the right, the left is always easier. So I'm going to subtract this 2x over to the left side. 6x minus 2x gives me 4x minus 6 is less than 6. Now again, subtracting on both sides doesn't flip signs. It's only multiplying and dividing by a negative on both sides that flip signs. Okay, next I need to add that 6 over. So 4x is less than 12. Dividing by a positive 4 here is not going to flip any signs. I'm going to get x is less than 3. Less than 3 on my number line. It's an open circle because there's no equal to, pointing left over to -infinity and 3 parentheses for both. And my last one here, just trying to make it a little bit more challenging. We do have some distribution we're going to do. We're going to take care of that right away. Makes it 2x minus 10 minus 5x is greater than or equal to x minus 8. I see I have multiple x terms. First, I want to do same side cleanup. So I have a positive 2x and negative 5x on the same side. Remember, some people make the mistake of thinking you got to add 5. You know, you're only changing sides if you want to go to the other side. The same side, keep the signs they are. So 2x, negative 5x is negative 3x minus 10 is greater than or equal to x minus 8. And then let me bring this x over here, minus x to make it negative 4x minus 10 greater than or equal to negative 8. Add 10, negative 4x greater than or equal to 2. Divide -4, divide -4, dividing by that negative. So that's that special rule. So that's going to change my sign from greater than or equal to less than or equal to. Negative, now 2 divided by -4 is -1/2. So I got a fraction here. That's okay. So on our number line at -1/2, we're going to do a closed circle because we're equal to, pointing left, down to -infinity. And -1/2, we have a bracket for that because the equal to and a parenthesis for that. And that's it. So it's just like solving equations. The big difference is you got to watch out for that one multiplier divide, flip your inequality sign rule. And then your answer is not going to be as simple as x equals 4. It's going to be an inequality which can be represented as an inequality notation, an interval notation, or graphically. But that's solving inequalities.